Okay, this is a lesson on how to balance complex redox reactions. The first thing that you will notice is that you will be responsible to identify the oxidation half reaction and the reduction half reaction. Then for each half reaction, you will be balancing all of the elements except hydrogen and oxygen. You will be balancing oxygen by adding water. You will be balancing hydrogen by using H+, and then finally you'll be balancing charges by using electrons. Once you are done with that, you're going to multiply the electrons of the two half reactions by factors such that both sides cancel out, and add the two half reactions together to achieve that balanced redox reaction. So what I'm going to show you is an example problem, a couple example problems. The first one we're going to look at is this MnO4 negative plus iron 2 resulting in Mn2 plus and Fe3 plus. Now the first thing you'll notice is that I'm going to ask you to balance this equation. You have oxygen here, but you do not have oxygen on the product side. So you might be saying, what's going on here? I'm going to tell you, don't worry. The adding of oxygen will come through your adding of the water molecule. So the first thing you're going to want to do, though, is you're going to want to evaluate oxidation numbers in order to determine what the reduction half reaction is and what the oxidation half reaction is. So the first thing you'll notice is that charges or ions that have a charge are the oxidation numbers. So you're good here. You know the oxidation number for Fe, you know the oxidation number here for the Mn2 plus, and you know the oxidation number for the iron 3 because they are the charges. You do not know the oxidation number for the Mn or the oxygen. So you're going to go and you're going to evaluate that. And if you'll recall, oxygen is a -2 charge. Manganese then has to be the +7 to give you that overall negative charge. Next, look at the tie lines. And you're going to determine who's losing electrons and who is gaining electrons. From here, you can write the oxidation and the reduction half reactions. We're going to start with the reduction half reaction. Notice that manganese goes from a +7 charge to a +2 charge. That means it gained electrons. Now you're going to write this half reaction just with the manganese MnO4 negative, the permanganate ion, going to the Mn2 plus ion. Notice then you are going to balance oxygens by adding water. So I'm adding 4 waters on the product side. The second step says you are going to balance hydrogens by adding H+. So since I have 4 waters, which then results in 8 hydrogens, I am going to add 8 H+ on this side. Finally, I am going to add the electrons in order to balance charge. To do this, you want to notice that there is a 7+ charge here, because here you got a negative charge and you got 8 hydrogens, so that's an 8+ charge. That results in a 7+ charge. On this side, you have a +2 charge on this side. So you are going to have to add 5 electrons. Now your net charge is +2 on this side and +2 on the product side. Notice the electrons are on the reactant side, which is where you want them for reduction. Now you are going to write the oxidation half reaction. Oxidation is happening because iron's going from a +2 charge to a +3 charge. You're losing electrons. Notice there's no hydrogens, there's no oxygens, so you don't need to add any of the water or the hydrogen ion, but you do need to add electrons. Notice this is a +2 charge, this is a +3 charge here on the product side, so we're going to add 1 electron, and now you have a balanced charge. Also, notice that the electrons on the product side, which is where you want it for oxidation. Finally, we can add these two reactions together in order to make a redox reaction. However, the electrons have to balance. The oxidation reaction only has 1 electron. The reduction reaction has 5 electrons. So what you will need to do is to add or multiply the oxidation reaction by 5. By doing this, this will result in 5 electrons on the product side, which will cancel the 5 electrons on the reactant side. So doing this work and combining the two terms together, I end up with MnO4 negative plus 8 hydrogens plus, there would be 5 electrons plus 5 Fe2 plus Mn2 plus 4 waters plus 5 Fe3 plus 5 electrons. The electrons cancel, so I removed them from the final answer, and that is what you should report. Notice the last thing you'll want to do is that you want to make sure that you balance in both charge and in elements. We're going to check elements first. 1 Mn, 1 Mn. 8 hydrogens, 8 hydrogens. 4 oxygens, 4 oxygens, 5 irons, and 5 irons. Next, we're going to check charge. This results in a plus 17 charge. Here we result in a plus 17 charge. So we have a balanced redox reaction. Here is another example we're going to do. The dichromate ion plus ethanol will result in a chrome plus 3 and CO2. First thing you're going to want to do is evaluate oxidation numbers. By doing that, I notice the oxidation numbers, and I notice that there are changes. For instance, chrome goes from a plus 6 to a plus 3, and carbon goes from a negative 2 to a plus 4 oxidation number. I do the tie lines, and I can determine that the dichromate ion is actually in reduction, and the carbon in ethanol is in oxidation. So the first thing I'm going to do is I'm going to write my reduction reaction. Then what I'm going to do is I'm going to go through those steps to balance this reduction half reaction. First step says balance elements that are not hydrogen and oxygen. Here I've got 2 chromes, here I only have 1. So I'm going to put a 2 in front of the chrome on the product side. Second step says balance things that are oxygens by adding water. So on the product side, I'm adding 7 waters. Third step says balance hydrogen by adding H+. So on the reactant side, I need to add 14 hydrogens. And the fourth and final step says that we have to balance charge. Notice here, this results in a plus 12 charge, and on the product side, we have a plus 6. So in order to make that balance, I need to add 6 electrons, which I'm adding right here, and I kind of double check that the electrons are on the reactant side. That's where they need to be for reduction. What I'd like for you to do now is I would like for you to pause, and I would like for, before you pause this though, I would like for you to write out the oxidation half reaction and balance that. Then resume the video here and see if you have the same results that I have for the oxidation half reaction. So hit pause, try balancing the oxidation half reaction, and then resume. Okay, so hopefully you are successful, that you have the same answer that I have here for the oxidation half reaction. We are now at the point where we want to add these 2 half reactions together to get a full redox reaction. But we cannot add them together because the electrons do not balance. So we need to take the reduction reaction and we need to multiply this whole reaction by 2 because there's only 6 electrons on the reactant side for the reduction reaction, and there's 12 electrons on the product side for the oxidation. So that is what I'm going to do, is I'm going to multiply that top equation by 2 and then add the two equations together to get the balanced redox. When I do that, I get something that looks like this, all of these terms together. The first thing you'll want to notice is that the electrons here are going to cancel out. So I'm going to cancel out the electrons. I am also going to cancel out like terms. So for instance, here you have 28 hydrogen ions, and on this side you have 12 hydrogen ions. So this is going to also cancel or reduce, and this number will change to 16. Look at the waters. You have 3 waters on the reactant side. On the product side, you have 14 waters, so that will also cancel, or I'm sorry, reduce, where these will be gone, and this will result in 11 waters, which is what I've done right here. Finally, you rewrite the final equation. Notice with simplified terms, the electrons are gone. And finally, you check charge and elements that they have balanced. Let's check elements first. Here you've got 4 chromes. On this side you have 4 chromes. You have 14 oxygens plus 1 more is 15 oxygens. Here you've got 11 oxygens plus 4 is 15. Here you've got 16, 22 hydrogens. On the product side you have 22 hydrogens. You've got 2 carbons and you've got 2 carbons. So you're balanced in elements, and you will notice you are balanced in charge, because here you've got a -4 plus 16 positive makes 12 positive. 4 times 3 positive makes 12 positive. You have a balanced redox reaction. This was a tutorial on how to balance complex redox reactions. I hope this helps, and good luck.